There is an old saying that goes, the harder I work, the luckier I get. Let us continue working hard by doing more questions so that we can increase our chances of being lucky when we go to our exams. In order for me to solve question 2, I am going to use the academic constitution. The academic constitution is a problem-solving strategy that has 4 rules. The I rule, the C rule, the A rule, and the N rule. The I rule is the interpretation rule. So we interpret the given problem. To interpret this problem, I will first start by reading the problem statement, which says, a 10 kilogram object changes its velocity by 30 meters per second towards north. We are saying here that we have an object that has the mass is equals to 10 kg. So m is equals to 10 kg. And we say that this object changes its velocity by 30 meters per second. This means that this object would have moved to some new position here. But to move from this start position to that position, it has changed its velocity. In other words, we have delta V. Remember we talked about the letter delta. To say delta means change. So the velocity has changed by 30 meters per second to move from this position to that position. And we're saying here that it goes towards north. In other words, if I were to draw my cardinal points like this would be north and this would be east. Now I'm going to choose my direction such that north is positive. So this means that any vector that goes to the north will be positive. Hence here my change in velocity, I'm going to write it as 30 meters per second because it's going towards north, which I chose as the positive direction. Now at this stage, I've done the interpretation of the problem based on what I'm given. The second rule is classification of the problem. To classify the problem means we're going to link this problem to the theories that we know, the formulae that we know, and any concept of or principles that we have to study. When I look at this problem, it's a problem where I'm given the mass and the change in velocity. So I have mass and delta V, and I can see that this will come out to be the change in momentum. So for me, this problem links to change in momentum. I should expect questions that will require me to understand the change in momentum and do calculations around that area. So we are done with problem classification. We now have a full understanding of this problem. We can move to the rule of A, which stands for answering the questions. We go directly to answer the questions now. Rule 3. Question 2.1 says to us, define the term change in momentum. We know this definition from lesson 2. We spoke about that in detail. And we defined change in momentum in that lesson to be the difference between the final momentum and initial momentum. Now we are done with rule number 3. We go to rule number 4, the last rule, the N rule. The N stands for navigation. In this rule, we are going to navigate our answer, the answer that we got. We're going to navigate our answer. To navigate the answer would mean that we check our answer to see that it makes sense and it doesn't have mistakes. And we answered what we were asked. So when I look at my statement here, I don't see any grammatic errors or anything that doesn't make sense. The straightforward answer to say the momentum is the difference between the final momentum and the initial momentum. And I don't see any errors in this. Now, this question is worth 2 marks. So they're going to give you 2 marks. This means that you need to spend a maximum of 2 minutes answering this question. If you have downloaded our free copy of the study guide and you are studying, this type of a question would be easy as time goes on because you'll be able to save time here. You can do this in less than 2 minutes. Then now we are ready to do question 2.2 that says calculate the change in momentum of the object. So basically, I'm going back to rule number 3 to answer the next question. So here we are required to calculate the change in momentum. Now already I've written the formula of calculating this when I was doing problem classification at the beginning of the video. Now that's the formula that we're going to use for finding the change in momentum. And we know that we have the mass of 10 and we know that the momentum, the change in velocity here, the object changes its velocity by 30 meters per second. And 10 times 30, that should be a 300 kilogram meters per second, right? So this would be my final answer. And because this answer is positive, I'll further then attach direction to it because I know that change in momentum is a vector quantity. So anything that is positive, it means it goes to the north. So here I'm going to write northwards. So it's 300 kilogram meters per second northwards. Because we are done answering this question, we are going to jump into the last rule of navigation. We have to navigate our answer. I've written here that my change in momentum is that number. I have written the number here and the SI unit. Very important. Then I've also put direction. So I don't see any errors here. Everything looks good. This number here is about 300 kilograms. It's quite a big number. But remember, if we look at our question, they just said an object. We don't know what type of an object this could be. It could be a bullet. Then this answer will make sense because bullets, they tend to have a bigger momentum. It could be a different type of object that can have this type of momentum. So it's very difficult to say, whether this number is big for whatever object we're dealing with or small. But we can see that, it's 10 times the change in momentum. So it looks good. There's no much errors there. The other thing is the direction. Remember that the change in velocity is directly proportional to the change in momentum. So if our change in velocity is going towards the north, we also expect our change in momentum to be actually a vector that goes to the north. So our answer looks good in terms of navigation. Very important to do this because actually you can mark yourself or know if you are in the right direction when you solve problems in your question paper. It's a very useful skill to have. Rule number 4, problem navigation. Now we are given a statement here below question 2.2 that says that suppose the object increased its velocity to 80 meters per second to change its velocity by 30 meters per second. Now what they are saying here in this problem, they are actually taking us back to rule number 1 because we have new information. We have to reinterpret the problem. So here we are told that to increase the velocity, I'm going to go to my initial diagram to do the interpretation. They're saying that to increase, we increased our velocity by 80 meters per second. Obviously, to increase the velocity would mean that we moved from an initial unknown velocity here and went to a new velocity, which will be final velocity here, right? That's the increase we have done so that we can achieve this change in velocity. So this means here we are given the final velocity as 8 because is what we have increased, right, to change our momentum by 30. So what we have increased to, the value that we have increased to, right, from the initial velocity, so that we can have this change in velocity, right? So we are given 80 meters per second as the final velocity there. Now the question continues now to 2.3 that says now calculate the initial velocity. And I mean in our interpretation we can see that our initial velocity we don't have. We just know how much it has increased by, right? It has increased to, not by. It has increased to, we know that it has increased to 80. So now here we are looking for the initial velocity. Again, to do this problem, I'm going to classify it as a problem that requires, again, the concept of change in momentum because I can see how this formula will still fit in solving this problem. So that's classification of the problem. Then we're going to go to answering the problem. Now I'm going to use the formula of change in momentum, but in this case, because I have velocities, right? I'm looking for the initial velocity, I have the final velocity. I'm going to rewrite this formula in terms of velocity. I'm not going to write it in terms of change in velocity. So this means I'm going to have the mass times the final velocity minus the mass times the initial velocity. And from here, it becomes a substitution problem because we know our change in velocity from the previous question, which is going to be 300 meters per second, 300 kilogram meters per second. And we know that our mass is 10. Our final velocity, we said it has increased to 80. Then we have the 10 and we are looking for the initial velocity. Now here I'm going to have a 300 and here I'm going to have an 800 because I'm just multiplying by a 10. Then here I just have a 10 VI. At this stage, I will then take the 800 to this side so that I have 300 minus 800 and 3 minus 8, that should be 5. But because I'm subtracting a small number from a big number, I'm going to have a negative 500. And this side, I'm going to have a negative 10 times the initial velocity. I'm going to divide here by the negative 10 on both sides because what I do on the left, I also do on the right. So that the 10, the negative 10 cancels this side. And I'm going to be only left with the initial velocity, which is what I'm looking for. This side, I'm going to divide the negative 500 by the negative 10. So this means I'm going to have the initial velocity is equals to negative 500 divided by negative 10. That should be 50 because, the 0 and the 0 would cancel here. so that I'm only left with a 50. Or you can use a calculator. You are allowed to do that. But very important, we have the negative and the negative cancelling each other out as well. So that here now I'm going to have a 50 meters per second as my velocity. Now, because this velocity is positive, it then means that the initial velocity should go northwards, because north is a positive direction that we chose. We have answered this problem. We are now ready to look at navigation. Do we have any errors in these problems? Do we have any mistakes that we can spot from the final answer? That's what navigation is all about. So here I've written my initial velocity to be equal to 50 meters per second. The number and the SI units are there, and I've attached direction. But does this direction make sense? If we look at our initial velocity, it must actually go upwards as well. It should be a vector that goes upwards, because if this thing starts going upwards, it will be able to reach this point. If it were to be like this, to go downwards, it should come down somewhere here. So this answer makes sense. And definitely you can see that this will give me a correct change in velocity, in the sense that if you say 80, which is the final velocity, minus the 50 here, remember we found this to be 50 meters per second, you will get the 30, right? So it does make sense. And this will be out of 3 marks, right? So this question and this question is 3 marks here. I'm just going to go back to this one as well to mark both of them to see how they are going to mark us. 1 mark for writing the formula for substitution and the final answer. That is 3 marks. 1 mark again for the formula for correct substitution and the final answer. So it means on each of these questions you must spend a maximum of 3 minutes.